And now, with the concept of a cross product, we are ready to define torque as a vector. So here's our wrench about to be rotated about point P by a force applied at this location, rotating it like that. So our vectors, our relevant vectors, would be the position vector r pointing from the point of rotation P to the location where the force is being applied. And then there's our force vector. If we put them tail to tail, we see that this theta there is the relevant angle between them. I've also shown the force vector broken up into a component parallel to r and the component perpendicular to r, and it's that perpendicular component that will contribute the torque. Our definition for the torque exerted about point P by this force here is given as this cross product. The torque vector is defined as the result of r cross F. This vector product gives a new vector, the torque. We know how to find the magnitude of this cross product. Well, what I want to talk about here is the direction of that cross product. So r cross F. In this picture, we'll take our fingertips, point them in the direction of r with our palm pointed towards F, and curl those fingers, r curled towards F, and our thumb points in the resulting direction of the torque. So in these x, y, z axes, we see that if r is in the x direction and the perpendicular component of the force is in the y direction, then r cross F will point in the direction of I hat cross j hat. It'll be in the k hat direction. The torque vector points in the k hat direction and is given by this expression here. Magnitude of r times magnitude of F times sine of that angle between them, pointing in the k hat direction. The torque vector points along the axis of the rotation that the force would tend to cause about point P. So this force would tend to cause our wrench to rotate about the z-axis. So the torque that results from that force points along the z-axis. Here's another application of the right-hand rule. Right-hand rule means many things. We've talked about what it means in terms of a cross product. Here's another application. Let the fingers of your right hand curl in the direction of the rotation as if you were grabbing the axis of rotation. And then your thumb will point in the direction of the torque vector. So here, if the rotation is sort of this counterclockwise rotation in the xy plane, make your fingers curl in the direction of that rotation, and your thumb will be pointing in the z direction of the torque. Like you're grabbing onto that z-axis, grabbing onto it and rotating around it. Your thumb points in the direction of that torque vector. Here's another illustration. If, say, we were going to try to rotate that wrench the other direction, clockwise in the xy plane, by applying a force like this, then here where our vectors would be, there's r, there's F. Let's do r cross F to find the torque. Fingertips in the direction of r, palm towards F, r crossed with F, and our thumb will point in the negative z direction. To be clear, r would be in the j hat direction here, and the perpendicular component of the force would be in the I hat direction. So j hat crossed with I hat, get out your right hand, j hat cross I hat points in the negative z direction. So the torque in this case would be given by this expression. The torque vector would be given by magnitude of r times the magnitude of F times sine of that angle between the r and F vectors, and then the direction is negative k hat. We can imagine grabbing onto that z-axis in such a way that our fingers curl in the direction of the rotation. Sort of a clockwise curl to the fingers, grab that z-axis like grabbing onto a rod, and our thumb is pointing downward in the negative z direction. There's our torque vector in this case, opposite the direction of the torque vector here. So we see that by flipping the direction of rotation from counterclockwise to clockwise, by flipping the direction of the rotation, we have to flip our hand and flip our thumb. So our torque vector flips from being positive z to negative z when we flip the direction of rotation. That's equivalent to sort of I was about to say flipping the direction of these, flipping those two, but never mind that. Strike the last few moments from the record. I think we've covered it.